This is Jeff Couch.
Yes,
and you are with ArduSat. What the heck?
So
is
ArduSat?
It sounds like some kind of medical procedure of some kind.
Kinda, right?
Yeah.
So what it is, it's an Arduino-based product, right?
So real quick, tell us what Arduino is.
Arduino. This is an Arduino right here. This little board. It's a microcontroller. It's an open source computing platform, basically. What it is, right? Millions of them worldwide. It's really big in the makers and hobbyists and things like that. It's getting big in education. So we provide Arduinos to the classroom along with this sensor board right here. This board has 9 different sensors on it, and you get 20 different readings off of it.
Okay.
Things like luminosity, ultraviolet light, infrared temperature, ambient temperature, gyroscope, magnetometers, and I can't remember how many that is, but there's 9 of them on there.
9 billion sensors.
9 sensors.
Okay.
So, and then you also have fun things with like a MakerBit. You get LED lights and wires and breadboards, so students can wire up their own experiments.
They come with instructions on how to wire up their own experiments, or do they just randomly start plugging things
right here,
in?
I'll walk you through an experiment.
Okay, tell me how this all works.
What this is an example of some of our curriculum here. So this is a sunglasses experiment.
So it comes with curriculum. So
yes.
Okay.
Yep. So what we do is
What grade level are we talking about?
We actually are in 2nd grade through high school.
Okay.
Majority of our schools are middle school and high schools.
Right.
But we do have as young as 2nd grade.
Okay.
So this is an example to running an experiment on UV light and luminosity.
Okay.
So I'm going to...
And that means you must have a sensor back here on UV light, right there.
Yep.
Okay.
Yep. In there. So this can be edited or created from scratch by the teacher. And down here, here's a simple wiring diagram. There are more complex ones that we can do. Right?
Okay.
And then right here is the code that you would need to use. It's down here on the bottom. I would simply hit run on Arduino.
So the code's already written, the kids don't have to write the code?
Correct.
Can they write their own code?
They can write their own code or edit the code we provide as well.
Okay.
So either one.
So the Arduino board that comes with this, is this like a standard Arduino board that everybody, like,
yes,
there's millions of these out there.
Yep, so we use what's called the SparkFun Red board, which is an Arduino Uno.
Thus, the reason it's red.
Yes.
Yep. See, I'm clever.
And then I'll come down here a little bit more, and right here we'll actually run an experiment. So I'm going to go ahead and connect to the Arduino. And so when I do that, I'm getting live data readings from this sensor board right now. So,
so right this second,
you see that? Okay. So I'm going to watch what happens when I put the light on this. You're going to see my luminosity spike significantly, right? Yeah. I'm not getting much of a UV reading because we're inside, but when I take that off, luminosity goes down. Put it back on there. So what we would do in the students is we would come down here a little bit more, and I would simply take a baseline reading, and I'm going to get some actual data, right? Some hard data there, and I'm going to build out a graph as well.
Okay.
So I'm going to pretend I have a few pair of sunglasses in my hand, and I'm going to take a reading here. I'm going to say reading, that's sunglass 1, maybe sunglass 2, and then sunglass 3 up here.
Okay.
And then there's my data right there. And a simple graph showing what happened with each of them, right? And then the student could come down here and they could actually type in, explain what happened with the conclusion. And if this was an assignment that I as a teacher had actually submitted to the students, down here on the bottom they would have a submit button that they could then submit it back to me.
Okay, so now this, just looking at it, and of course we've just met, so so it looks kind of like a cookie cutter kind of lab. The students do X, Y, Z. So where does the part come in where creativity hits?
It can be. Great question. So it can be cookie cutter, or it can be students running and doing their own things.
Because we want to try to get away from cookie cutter lab.
Yep. So this is what this example is. This is an example of curriculum that I as a teacher have created myself, right?
Right.
We've done other things where, great example is we had a group in Florida over the summer do a STEAM camp. And what they did is they took our sensor board and they wanted to test crash cushions for a barricade on the side of the road, right? And see what would be the safest type of crash cushion. So what they did is they were engineering different types of cushioning, and then they would strap this onto basically a Pinewood Derby car and run it down a ramp into their cushions that they created, and they would take the G-force readings, and then they would go in and re-engineer their cushions over the week.
Right. Okay. And so I can also see where they're like, even for this one where they're doing the UV rating. they could play with the variables. They could play with all the different, and then teacher might present a problem at the end, say which is the best sunglass and why.
Yep.
And then they'd have to talk about why the results that they got are good results or bad results.
Exactly. And then also things like the classic egg drop experiment, right? Rather than having an egg and getting yolk or not, we put this into a little container and make this be our egg, right? And we take G-force readings on impact to get an understanding of what happened.
And they don't break.
Yeah. We haven't had one break yet. I can't promise that, but not one yet.
You never know. Okay, so what's the cost of these? How much do they run?
So the way it works is we break it into two different parts, right? So you have the hardware components. You get 10 or 15 of these.
They come in packs, right?
They come in packs of 10 or 15, and that's $2,000.
Okay.
For the hardware, and then we do an annual site license for the software platform. And what that means by site licenses is for the entire school. Any student, teacher, anybody involved there will have a license to it.
For the software, but the software is not open source software?
The curriculum is open source, but what you get with the paid subscription is you actually get some teacher management tools. So I'm going to click into that.
So are there other teachers adding to these as well?
Yes.
Okay.
Yep.
So you've set up kind of like a little learning management system?
Kind of.
Okay.
Yep, absolutely. And sorry, the internet's being really slow in here.
That's all right.
But it's not going to take me to the back office. But with the paid subscription, what you get is the teacher actually gets to copy and create their own curriculum,
right,
rather than just viewing ours. And then the students actually get to save their data set and submit that assignment back to the teacher as well.
That's cool.
So,
that's cool. Jeff.
Yes.
So if they're $10 pack for $2,000, so that makes it $200 each, right?
And then the hardware is. The software is in elementary school is $1,000 per year. Middle school and a high school is $2,500 per year.
And for a whole district, it's $1 billion.
$1 billion.
$1 billion.
We do
a good
volume
deal.
discounts for an entire district as well. So, and then that also includes your training and your support and professional development.
And then I assume there's like some online resources as well that go with this.
Absolutely.
So it's not just the teacher one-time training and then they get lost.
And we got a great support team there for them as well.
So what courses do you see this embedded in? I could see, of course, physics. That makes sense.
Earth sciences, life sciences, been a lot of them. General middle school science.
Math, I would think.
We've done a lot of math.
Yeah.
I shouldn't say a lot. That's becoming more popular. Math, going in and analyzing the data. Computer science, CTE, a lot of CTE and maker movement, right? There's a lot of maker stuff you can do with the kid as well.
Right, a lot of school districts are making maker spaces for their kids. Yeah,
absolutely. And then also elementary schools. Elementary school age students wiring up LED lights and getting them to blink and changing the code and getting them to blink faster, trying to time it to music and things like that as well.
That's awesome. Okay, so Jeff, if they're interested in ArduSat, and you look at it, student design experiments from Earth to space.
And I need to touch about that. So the space component is we partner with a company called Spire, and Spire actually makes satellites this size. It's called a CubeSat.
Well, you can just like put that on a rubber band and fling it into space, right?
Basically.
Like, who needs a rocket?
And on every one of Spire's satellites, or CubeSats, we have our sensor board, the same one in the classroom. So once a year with that subscription, your school actually gets to send an experiment to space and run using our sensor board as well.
Wow, that's awesome. So, and then they get the results back.
They get the results back and analyze it in the system.
That's cool.
Yeah, super fun.
Crowd-sourced satellite experiments. That's awesome.
Actually how Spire came to be. With their CubeSats was crowdsourced through Kickstarter.
That's sweet. That's sweet. All right, ArduSat.
Yes.
Where do we get the information?
Right here. You can focus on my thing there. You can email me or just simply go to ArduSat.com.
ArduSat.com or Jeff Couch, and we'll just go to your house and sit out on your front porch.
That'd be awesome.
Okay, Jeff, thanks for talking to us.
Appreciate it.